Alright, so hopefully you tried the other one on your own here, but let's just go through this, make sure you got the same thing. So we're going to start by drawing out the molecule that we're starting with, the organic molecule. Here it is here. Okay, and so there's the molecule there in the condensed structural form. Let's draw a picture of it. There it is there without all the hydrogens. And let's draw it in that three-dimensional way like I drew the other one with the iodine kind of sticking out front. Okay, so once again, I have four things attached to this carbon here. Okay, in particular, I have an iodine, a methyl group, and a propyl group. Okay, so I'm going to stick those on. I'm going to put the iodine out front, and the rest of it, I don't really care where it goes. C there, a C here, and a C, C, C there. It doesn't really matter where you put them at this point. Okay, and then so the first step in this equation, now, and just so you know, this is going to come up again later when we start talking about molecular shape and whatnot. So I am trying to help you out here, believe it or not trying to confuse you. I know that's what's happening anyways, but hey, you joined IB. So I'm going to now, we're going to do the first step in an SN1 mechanism, which is where the halogen leaves first. So I draw those arrows like that. Okay, and when that halogen leaves, it leaves behind a three-membered ion. So there's my central carbon again. I'm missing the iodine there, so I have these other three rather things that are left behind. There's a C there, and there's my CCC. They're left behind, leaving behind a positive charge. That's my carbocation. Okay, and the iodine is over here somewhere. And this is one today where I said that it doesn't really matter which side you attach the OH to. It can happen from either side. The implications are vast, but that's beyond us really in IB Chemistry 11 or 12 for that matter. And so I'm going to draw my nucleophile. Okay, here it is here. It has three pairs of electrons. One of those pairs, doesn't matter which one. Okay, let's get rid of this plus sign here. I'll put it on the other side here. Okay, there's my curly arrow showing my nucleophile attacking. Okay, and then all I need to do is draw the final product. And when I do that, again, the umbrella kind of flops over away from the nucleophile. So all those, like these guys here, this thing here, they all kind of flop over this way a little bit to kind of spread out away from the hydroxide. Okay, so there's the carbon, the central carbon and the hydroxide, and then off towards the back is that top carbon there. This guy here is that one. Okay. And then the one coming out towards you and going away from you into the page there. Okay, that gives you that carbon there. And then CCC attached there. Okay. And you don't need to draw it particularly well at this point. We're just kind of getting a hold of this. But those three steps are the important ones. Okay, so again, three steps. There's your initial phase here. Okay, we have everything there, and then the halogen leaves, leaving behind a transition state, a carbocation, which is this guy here. And again, this is there, but not super necessary to draw. Okay, and then you have to draw the nucleophile attacking, and there's the final product, which is a tertiary tertiary alcohol. Okay, and I know it's tertiary because that carbon has one, two, three other carbons attached to it, so it's tertiary. Okay, so hopefully that helps you out a little bit and you feel a little bit better about this stuff. And if you don't, sucks to be you. No, we will discuss it more next time I see you. Okay, see ya. Have a great long weekend. Or if this is Tuesday night, you procrastinated too long.